probability chapter. Find probability of E given that F has occurred when three coins are tossed. When three coins are tossed, you have to find out probability of E given that F has already occurred. It's a problem number 6. Under that we have got the third problem. This is third problem. See, when three coins are tossed, we have to find out the sample space. As usual, that will be 8 in number. I have told you earlier about this. And what is the event? At most 2 tails there should be. See, at most 2 tails means it can be less than 2 also. It can be less than 2 also, but it should not be more than 2 tails. At least 1 tail means it can be more than 1 tail also. It can be more than 1. So, according to this rule, we will collect elements under E and F. Look here, E, C, H, and these are the elements according to that rule. So, look here, at most 2 tails. There are at most 2 tails. There can be one. One tail is here, one tail is here, one tail is here, 2 tails. 2 tails are here and 2 tails. It cannot be more than 2 tails, and it can have no tail at all. So that's also possible. It can have no tail at all. It can have 2 tails, 2 tails, 2 tails, 1 tail also. 1 tail and 1 tail. So it can have 1 tail, it can have 2 tails, it cannot have 3 tails, and it cannot, and even it may not have tails at all, HH like this. So in that way we have to collect these elements from out of the sample space. Yes. Now, how many of them are there? 1, 2, 3, 4, 5, 6, 7 are there. 7 out of 8. Therefore, the probability of E is 7 by 8. Now, F. What is F? At least 1 tail there should be. It can be more than 1 also. It can be more than 1 tail also. Look here. F. At least 2 tails. The 1 tail we can have. 1 tail we can have. 1 tail we can have. 2 tails we have here. 2 tails we have here. And 2 tails and 3 tails. It can be more than 2 also. F. Yeah. At least 1 tail. There should be at least 1 tail. Not less than that. Yeah. And you cannot have this. Okay, this you cannot have. HH. It does not have any tail at all. Like this. So in that way you have to collect. So what is the probability of F? 4 by 8. How many of them are there? Only 4. 1, 2, 3. 7 by 8. 1, 2, 3, 4, 5, 6, 7. So 7 by 8 is the probability of F, PF. Now we have to find out E intersection F. E intersection F means the common elements between E and F. Okay, common elements, I have marked them. 1, 2, 3, 4, 5, 6, and here also 1, 2, 3, 4, 5, 6. So these 6 elements are common between these 2 sets. That is E intersection F. Okay, I have collected also. E intersection F is this one. How many of them are there? 1, 2, 3, 4, 5, 6. So common elements between E and F. Here, E and F. Look here, HHT, HHT, HTH, HTH, THH, THH, HTT, HTT, ಆಮೇಲೆ and then THT, THT, and then TTH, TT, like this, common elements. So how many of them are there? 6. So probability of E intersection F is 6 by 8. That is 3 by 4. So all these things we have found out. Now finally we will find out the probability of E given that F has already occurred. That is the simple formula. Probability of E intersection F by PF. P intersection F how much? 3 by 4. And PF how much? 7 by 8. Now you calculate this. 3 by 4 divided by this one means 8 by 7. 8 by 7 means how much? Look here. Here we have got 8. This 8 is divisible by 4. 4 2s are 2 3s are 6, and what remains? 7. So the probability of E intersect E given that F has occurred is equal to 6 by 7. Only important thing is you must know the meaning of at most 2 tails, at least 1 tail. At most means it can be less than 2 also. At least 1 tail means it can be more than 1 also. So in that way we have to collect elements under E and F. I hope you have followed the problem. Thank you.